Let's begin by having you just take a general look at these questions first and see how the answers to this part of your homework compares to the answers to that you got last night. And then I want to draw some general concepts out of this, flesh it out a little bit, and then we will proceed with today's lesson. So, you should be comparing your answers. I see too many people, way too many people, who do not have their answers out right now on their desk taking a look. Of all of the things that we go over this year, the one that requires the most diligence, the most daily work is factoring. The reason is because it's just training your mind to rattle through numbers relatively quickly. It's kind of like learning the times tables on steroids, because you have to do multiple things with timetables. And if you're able to do that, factoring comes really easy. If you're not able to do that, factoring can be very frustrating. So we want to make sure you're good on all of these fronts. Okay, another 30 seconds or so, and then some generalizations. Okay, so my first question to you is, are there any particular items on here with which, or that you do not understand, or with which you disagree? So are there any of these that you want me to explain how I came up with my answer? Yes?
Two.
You look for the greatest common factor, right? We always do it. What do you always do before you cross the road?
Yeah. You look for them.
Good, and we always look for the greatest common factor. So they share a 3 and they share an a squared in common, right?
Yeah.
Good. So I pull out, or I factor out, that 3a squared, and that leaves me,
What'd you do?
that leaves me, when I pull out the 3a squared, what's left here? Well, I think it's an a. And then when I pull out the 3a squared here, oh, look at that. See? If I would have done a quick mental check, it wouldn't have worked. This should be a 3.
See?
Okay?
Oh, that's what you were talking
Yeah.
about?
All right. Any other questions? See, I didn't do a quick mental check and I got it wrong.
See?
Always, always, always do a
Not
quick mental
crazy,
check.
dog.
What was it I mentioned about
I
brain
thought you were
chemistry?
talking about the 3A.
All right. Any other questions on here? All right. So yes. 9. Number 9. Okay. Well, that leads me to what I wanted to say just a moment before. So I'm going to say it and then I'll do number 9. Factoring is very much a step-by-step process. Now, the first thing you always do, just like you look both ways before you cross the road, you always, 100% of the time, look for a common factor. So there was a common factor on number 2, there was a common factor on number 3. Then the next thing you do is you say, okay, if there's no common factor, is it a trinomial, like on number 5 or number 6 or number 7, and then you go with the AM method. But then you look and you encounter a trinomial like number 8, and you compare that to the trinomial in number 9. And the difference between the trinomial in number 8 and the trinomial in number 9 is that the trinomial in number 8, they have a common factor of 2. So I have to first pull that 2 out and then factor the resulting trinomial. Remember yesterday we spoke of the phrase factor completely, and how there is absolutely a hidden meaning behind that factor completely. You know, I record the lesson, obviously, and perhaps I shouldn't say this because perhaps New York State could get me in trouble on Regents exams, and I'm not saying I ever did this, but when you administer a Regents exam, you can't help kids with questions. But let's say I was to have a kid in my class who was like me as a student. Well, as a student, there were very few things I ever misunderstood. But I am prone to the brain cramp. I am prone to the absolute idiot mistake. Anybody else like that in the room? Now, if I'm proctoring the test and, you know, you ask me a general question, without being specific, I would never, ever, ever be specific and point to a question and say this, but I would say the general phrase, no brain cramps, which is like really saying what?
Don't screw it up.
Don't screw it up, be careful here. Now, I don't think that's giving anything away on the test, so I don't think I would ever get in trouble for that. But, no brain cramps might sound like the words no brain and cramps, but we all know what those words mean. So, when you're factoring, if you see the phrase factor completely, what that's really saying to you is you must use two steps. And anytime you have a trinomial, like number 8, and you factor out this 2, and then you're left with another trinomial, there's a very good chance you're going to need to factor the resulting trinomial. So that's a factor completely situation, and you should learn to recognize that. Now, on number 9, there's no 2 in common because of that 15n in the middle. 2 doesn't go into 15. So when there is no common factor, we go to the very aptly named Plan B. And Plan B just means I'm going to try an alternative strategy. So I'm going to take the 2 and I multiply it at the end. And that gives me a whole new trinomial. N squared minus 15n, but 8 times 2 is 16. Now, if you're on top of your game, you're saying you can't just go changing questions. I'm going to answer that in just a second. I factor that. It's n minus 16 times n plus 1. Now, because I multiplied the last term by 2 here, I have to divide the 2 back in to balance that. And when I do, 16 divided by 2 is 8. And when I cannot do the division, I do the elementary school trick. 2 times n is 2n plus 1. Francesca. Okay, did I answer it? Sorry. Okay, any other questions? Oh, the other thing is after I'm done, again, so the process, find the greatest common factor. If there's no greatest common factor and it's a trinomial, use the AM method. If there's a number in front of the x squared, like there is in both of these cases, or the variable squared, I'm going to look for a common factor like number 8, and then factor the trinomial. If there is no common factor, I'm going to plan B it like number 9. And then there's this one that seems, Emma, a little bit off on its own, that's really not off on its own. And that's ones like number 4. This we call the difference. What does difference mean in math? Subtraction of 2 perfect squares. Now, what that means is I can do the square root of x squared and I can do the square root of 121. Now, this only happens when there's 2 of them. It's a binomial, x squared minus 121, and it only works when you can take the square root of both. Now, some students will think of this as a very special case, and you can. There's nothing wrong with that. However, it really is, if you really truly think about it, it's x squared plus 0x minus 121. So I just have to multiply out to negative 121 and add up to 0. Okay, and then you can put it all together on one like number 13, where yes, you factor out the 5 they share in common, and then you have to factor the difference of 2 perfect squares, and plus 10 and minus 10. Okay? This represents everything you will ever need to know about factoring. Right through, well, almost through 11th grade. And if you can get all of these right, you're in perfect shape. Go ahead.
For number 9, just say it was like n minus 8 divided by 2. Would you still just divide it regularly?
I would make it 4. 8 over 2 would be 4.
Okay.
Yeah, if it's reducible, always reduce it. If it's not reducible, elementary school. Okay? Any questions? Okay. So, that covers our review of last night's homework. Now, the next thing I want to do is talk about today's Do It. And here are some very nice factoring questions that I hope you run right through. I hope you look at these questions like, not a big deal. I can get these anytime, any place. First one, x plus 7, x plus 1. Agree? Good. What's the answer to number 8? The next one. What do we got there? Miss Tongle, you're either conducting an orchestra or volunteering to do this one. Which would it be?
M plus 10, so M
M plus
minus 9.
10, M minus 9 is correctamundo, as Fonzie would say. And don't tell me you don't know who Fonzie is.
I know who Fonzie is.
Who's
Oh, wait,
Fonzie?
yeah, I know.
He's from that show from.
Happy Days.
Oh, that is the thing.
Yep.
My mom made me watch it.
Oh, that's a great show, rather than the garbage you guys watch on TV.
Listen.
No, listen about it. The difference between Happy Days and the Kardashians is practically good
That
and
no one
evil.
watches the Kardashians.
Oh, you'd be surprised.
It's such a
Okay.
stupid show.
Number 9. Factor that. Let's go. Who's going to help me on number 9? Don't be a wimp. Let's go, Pringle. What do we got? Yo. What do we got?
I don't know.
If you don't know, you're in a world of trouble for the next test. I'm telling you now. Look, you see the calendar over there? Do you see how the tests are right at the end of the market period?
Yeah.
No relearn packet.
Okay.
So we better produce the first time.
When is the
James,
game?
K minus 8, K minus 5 is correct. So, if you are like Pringle, if you really truly don't know, you had better learn tonight. Watch the videos, do what you gotta do, learn how to do this, because you're in a world of trouble, okay? And the next one is very, very, very strange, because I put the number first. It's very uncomfortable. What I would like to see you do with one like this, do you see how this v squared is positive? I would rearrange it. V squared positive, 99v positive, 100 negative. Then I would factor this as normal. This should be very comfortable to you. What would this one be?
V plus 100 would be
Yeah. And then I would go back and reverse them. 100 plus v, negative 1 plus v. And then it fits the format that they have. Notice, here the 100 was positive, right? So I keep the v positive. Here, the 1 was negative, so I keep the 1 negative. Okay? So that's how I would do it. I don't like factoring if the letter is at the end. Yes?
The letter at the end and negative, do you still do the same one?
Well, it's kind of strange. It gets extremely awkward, so I just avoid it like the plague. I reverse it, I factor it, and then I put it back together again, and then you could always do a quick mental check and make sure it works out. Okay? All right. It's also exceedingly rare that you ever have to do that. It's almost never done. Okay, everybody got your calculator out? Nice. All right, so let's talk about functions for just a minute. Functions take things and transform them. So, you've seen the movie Transformers? Okay. Well, when you see the movie Transformers, it starts with like a car and it turns into like Megatron. Now, I don't really watch the movie Transformers. I think I did watch the first one once, like on a Saturday afternoon in the rain, just because nothing else was on. But basically, these mechanical objects look like one thing and then they get transformed or changed into another thing. Now, that's what functions do. Functions take an input and turn it into an output. So that's one thing I want you to keep in the back of your mind when it comes to understanding this. Now, the next thing I want you to keep in the back of your mind when it comes to understanding this is exactly what division means. Let's just say, for argument's sake, that I have 8 x's. And I want to divide that by 4. Okay, I want to divide all 8 of my x's by 4. What that's really saying from a cognitive point of view is it's saying, look, if I have 8 x's, which means 8 of anything, it could be 8 calculators, it could be 8 sweaters, it could be 8 sweatshirts, it could be 8 pairs of shoes. If I divide them into 4 piles, how much would be in each pile? And everybody knows it would be 2. I'd have a pile with 2 x's, a pile with 2 x's, a pile with 2 x's, and a pile with 2 x's. So on your calculator, let's do some divisions and see that it works, okay? Let's take the number 20, and let's divide it by 10. So what that means is what? If I have 20 items and I make them into 10 piles or 10 groups, how much is in each group? 2, good. Now let's do 20 divided by 5.
Don't get all crazy.
And what do we get?
A lot.
So what does that mean?
That if you split them up into 5 groups, it's 4 in each group.
Right, in other words, if I had 20 items and instead of putting them into groups of, or 10 different groups, I only put them in 5 different groups, then that means there would be 4 items in there, which makes perfect sense because 5 groups is half of 10 groups, so it makes sense that you would have double the number in each group, right? Okay, good. What about if I do 20 divided by 2? Take 20 items, make it into 2 groups or 2 piles, and how much would be in each pile?
10.
Good. Now let's do 20 divided by 0.
No,
Error is right. How can you take 20 things and put them into no piles?
You throw them all out.
You can't. But then there's one pile, namely the garbage.
Well, what if you like shred them all up and then you put them in
She
like,
just likes to argue. doesn't she? Should I call you Lady Last Word?
go for it.
Lady Last Word. You always have to get in the last word.
Pretty much.
That's right. Okay. However, when we do division, the schematic, if you will, the comparison is to put it into groups or put it into piles. But I can't divide by 0 because I cannot take a known quantity and put it into no piles. It just doesn't make any sense. So, since it makes no sense, I can't really get a definition to it. And that gives us the new thing that we're learning today, which is called undefined. It's our first topic of the day. Undefined happens whenever there is a 0 in the denominator. For instance, 5 divided by 0 is undefined. Try it on your calculator. 5 divided by 0, and again, you will get an error message, okay? So we want to be able to recognize that situation and circumstance that 5 is being divided by 0. So sometimes you can just look at a problem and figure out, without doing any work, what makes something undefined. So for instance, for problem A here, what value of x could you put in the calculator that will make the value of the entire fraction undefined? -1, right? Because if you plugged in a -1, what would you get in the denominator? 0. What's -1 plus 1? 0. And then if I did 3 divided by 0 on my calculator, it would say error, 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 right?
But if you did 0 divided by 3.
Now that's fine. It's 0 in the denominator. The numerator I don't care about, only the denominator. What about letter B? What would it be, everybody? 7. I think we can look at it and by inspection, by a quick visual inspection, I think we can figure out what makes it undefined. What about letter C?
Never mind.
Okay, I'm going to imitate Phoebe. Ready? Everybody look at me. I'm going to do my Phoebe imitation. Never mind. There's something awkward about letter C. See, you could look at B and you're like, 7. But this is a little bit less easy. Now, the correct answer is -1/3. Very good. So, in addition to being able to solve some of these by inspection, it helps to have a process. It helps to have a process to allow us to figure out a way that always works. So one way that always works is to go back to the definition of undefined. The definition of undefined is whenever there's a 0 in the denominator. So if you look at it by inspection and you do a Phoebe, never mind. If you do one of those, just take the denominator and write equals 0. And then just solve it. All right, there we go. X equals -1/3. So there is a mechanical element to this that we can use to solve at all times too, okay? If we are looking for undefined, and if they give us something that's uncomfortable in the denominator, that is to say something that we can't just do with inspection, then all I do is just write equals 0 and solve it and I'm done. Make sense?
Look out.
Okay, floats your goat.
No, totes, not goats.
Whatever. Okay, next.
Whatever floats my
Now, next up, that's the first topic of the day. The next thing I want to do is talk to you about quadratic equations, okay? And quadratic equations, at this point, all comes down to your ability to factor. If you are good at factoring, this lesson is unbelievably easy. If, on the other hand, Julia's looking at me like she's, I'm in trouble. Now, if you're not good at factoring, then we're going to need a whole lot of help. I'm going to do the first one, show you how easy this is. Ready? First thing that's really different about a quadratic equation. Do you remember how when you solve a normal equation, like say 3x minus 2 equals 7, what's the first step? You add 2 to both sides. So in other words, when you solve a regular equation, what you want to do is, in the words of Miss Antos, or Mrs. Antos, you want to run away from the stinky cheese. Okay? Oh, she used to say it all the time. Basically, what you're doing is you're getting everything away from the variable being the stinky cheese. X is equal to 3. With a quadratic, you don't want to do that. You want everything on the side of the quadratic, and then you want to factor. So I just make this x minus 4 times x plus 1. In other words, we do AM right in the middle of the equation. We just do AM. It's as simple as that. Now, let's say, you ever see that show Penn and Teller?
No.
The magician guys?
No.
It's a pretty cool show. It's all about magic and so on and so forth. And I don't know if you know Nick Cristofaro. He's pretty good at it. He's a 7th grader. He's very good at magic. And my son Jimmy apparently
Oh,
likes magic.
yes I do.
He does.
Yeah, he's always doing the card tricks.
Yeah. Now,
Well,
here's the
not
thing.
anymore.
A little magic going on here, right? Ready? I have a number in each hand.
Okay.
I put the numbers behind my back. What I tell you is that when I multiply those numbers, I get 0. What can you tell me about the numbers behind my back?
0.
What about 0? One of them, no, that's not true, because a positive times a negative is a negative. One of them has to be 0. Do you know which one it is? No. Does it matter which one it is? No, because I could say 0 times any number, or any number times 0. I'm going to get 0 either way, and in fact, they could both be 0. So what I'm going to do is say, maybe it's the guy on the left, or maybe it's the guy on the right. And then just solve each one individually. X equals 4, x equals negative 1. And I'm done.
Wait. Don't do anything.
I'm going to give you a little hint here. Ready? Do you see how a quadratic has a little 2 here?
Yes.
That means there's 2 answers. And that's how you get your 2 answers. Okay?
Yeah.
Now, let's see you guys try x squared plus 4x minus 21 equals 0.
Okay.
Go ahead. Remember, factor it, and then maybe it's the guy on the left, maybe it's the guy on the right.
The world, you never know.
Could be both. Two numbers, multiply out to negative 21, add up to 4. If you have a hard time factoring, you put in y equals negative 21 divided by x, and you get to the table.
I
Okay,
think.
Phoebe, what did you get as factors?
Oh, no, it's even, I didn't want to answer. I got 3 and negative 7.
Good. So I'm going to get x, it's actually x plus 7 and x minus 3 as the
Oh, I thought you were
factors.
talking about the.
Right, you were talking about the solutions.
Yeah.
All right, so here's my factors, x plus 7 times x minus 3. Now, maybe it's the guy on the left, maybe it's the guy on the right. Minus 7 to both sides, x equals negative 7. Add 3 to both sides, x equals 3. Now, hold it, one last thought. One last thought. You've actually been doing this all year long. Go to your graphing calculator real quick.
Don't make
Type in y equals x squared plus 4x minus 21, and look for the zeros.
Don't you do it.
Look for the zeros. Type in that, y equals x squared plus 4x minus 21. Type in graph it, and the zeros are wherever it crosses the x-axis. Where does it cross the x-axis?
At 3
Negative 7 and positive 3. So this is the algebraic solution of the graphic one that you already knew. Guys, we have 3 more days of this, so don't worry if you don't get it today. 3 more days. Hasta la vista, vaya con Dios, toodaloo, ta-ta.